To finish this section, we are going to change some polar equations into their equivalent Cartesian equations, and then we're going to go the other way. We're going to start with some Cartesian equations and turn them into polar equations. So we're going to use the same bits of information that we used when we were converting the points back and forth. For the polar to Cartesian equations, we're going to make use of the fact that x is equal, there we go, x is equal to r cosine theta, and y is equal to r sine theta. By the way, this little table here shows some polar equations and their Cartesian equivalents. You can see there's some cases where the Cartesian equation is maybe simpler to look at. In other cases, like that last one, the polar equation might be simpler. So here we've got r cosine theta plus r sine theta equals 1. So just replacing, we have x plus y equals 1. And a lot of times it's going to be a straight line. A lot of times it'd be written like this. Y is negative x plus 1. So it would be a straight line, slope of negative 1, y-intercept of 1 as well. And that's all you have to do there. The second one, we have r equals cosecant theta e to the r cosine theta. Well, r cosine theta we know is x. But what do we do with this cosecant? Well, if you remember, cosecant is just 1 over sine theta. So I can multiply sine theta to both sides to get rid of that fraction, and that gives me r sine theta is equal to e to the r cosine theta. And then replacing, we have y equals e to the x. So there we would have the graph of the natural exponential function. So I'm going to do one more of these. Here I've got r equals 2 cosine theta plus 2 sine theta. And right now it doesn't look like what we're looking for, because remember, we know that x is equal to r cosine theta and y is equal to r sine theta. So it would help us if we had r's here on the right-hand side. Well, we can do that. I'm going to multiply through by r, and that gives us r squared is equal to 2r cosine theta plus 2r sine theta. Now, one of the other formulas that we had to relate Cartesian and polar coordinates is that r squared is equal to x squared plus y squared. And so on the left-hand side, I'm going to make use of that. So we have x squared plus y squared equals 2x plus 2y. And right now we have this written as a Cartesian equation, but I'm going to clean it up a little bit and make it look a little more familiar maybe. So what I'm going to do is I'm going to bring everything to the left-hand side. So x squared minus 2x, and notice I'm leaving a space there. Y squared minus 2y, I'm going to leave another space, equals 0. I'm going to complete the square. Half of 2 is 1, 1 squared is 1, so I'm going to do a plus 1 here, and whatever I do to the left, I have to do to the right. Same thing here with the y's. Half of 2 is 1, 1 squared is 1. So again, adding 1 to both sides. What this now gives me is x minus 1 quantity squared plus y minus 1 quantity squared equals 2. You might recognize this as the equation of a circle. It's a circle with center at the point 1, 1 and radius square root of 2. Now, we're going to do 2 more examples here to wrap up this section. The first one is x squared plus y squared equals 4. And we're going to make use of this bit, r squared equals x squared plus y squared. So we have r squared equals 4 or r equals 2. You could also write r equals a negative 2 there. For the second one, y squared equals 4x, this is one that is simpler looking as a Cartesian equation. We know that y is equal to r sine theta. So I have r sine theta squared equals 4 times x is r cosine theta. So squaring the left, I have r squared sine squared theta is equal to 4r cosine theta. And if I divide through by r, which is really the only thing I can do, I have r sine theta equals 4 cosine theta. And you can stop here if you want to. If you wanted to go one more step, you could divide both sides by sine theta and say that r is equal to 4 cosine over sine would be cotangent theta. And that would also be an equivalent equation.